Our universe is constantly expanding, which makes it incredibly difficult to define its boundaries or measure its true size. However, thanks to the James Webb Space Telescope, we now have the ability to peer deeper into the cosmos than ever before. Since its launch, numerous scientists, including Brian Cox, have made eye-opening revelations about the universe's vastness, a scale that is almost beyond human comprehension. Within the small portion of the universe we can currently observe, scientists estimate there are about 2 trillion galaxies. This number is based on studies of our local universe, but it's widely believed that what we can see is only a tiny fragment of a potentially infinite cosmos that remains beyond our grasp. We are not separate from the universe. We are a part of it. In a very real sense, we are the universe attempting to understand itself. With the James Webb Telescope, we are venturing into a monumental journey to uncover the true size and structure of the cosmos. If you're passionate about space and want to stay updated on new discoveries, be sure to like this video, subscribe to our channel, and turn on notifications. Now, let's put the scale of our universe into perspective. If you traveled at 70 miles per hour, it would take around 15 days to circle the Earth's equator. Reaching the moon would take approximately 5 months, and Mars, at its closest, would require about 63 years. To reach Neptune, it would take a staggering 4,400 years. These distances alone are enough to showcase the sheer scale of just our solar system. Take Voyager 1 as an example. Launched in 1977 at a speed of 38,000 miles per hour, it didn't exit the solar system until 2012, 35 years later. Even light, which travels fast enough to circle the Earth 7 times in a single second, appears slow when compared to the immense distances involved in space. Yet even our vast solar system is minuscule compared to the Milky Way galaxy, which contains roughly 300 billion stars. Many of these stars likely have their own planetary systems. Our nearest stellar neighbor, Alpha Centauri, is 4.3 light-years away. That means even if you could travel at the speed of light, it would still take over 4 years to get there. At Voyager's speed of 38,000 miles per hour, that same trip would take about 70,000 years. Now let's consider Velta Rouge, a star located 640 light-years from Earth. This means the light we see from it tonight actually left its surface 640 years ago, about a century before Columbus set sail for the Americas. That light has been traveling through space all this time just to reach us now. And yet, in cosmic terms, Velta Rouge is relatively close. Another fascinating concept is the radiosphere, the region of space reached by humanity's radio transmissions over the past century. So far, these signals have traveled roughly 100 light-years, potentially reaching about 15,000 star systems. Even so, this is just a sliver of the Milky Way, which contains hundreds of billions of stars. To visualize this, imagine shrinking our entire solar system down to the size of a U.S. quarter. In that scale, the Milky Way would be about the size of Earth. And scattered across this vast galactic planet are an estimated 300 billion star systems, each with their own planets, just like ours. But the scale doesn't stop there. Beyond the Milky Way, astronomers estimate there are at least 1 trillion other galaxies. Yes, 1 trillion. To grasp the enormity of that number, imagine 1,000 cats. Now picture 1,000 groups of 1,000 cats. That's 1,000,000 cats. 1 trillion is 1,000,000 times that number. Our nearest galactic neighbor, the Andromeda Galaxy, is 2.5 million light-years away. So when we look at Andromeda in the night sky, we're seeing it as it appeared 2.5 million years ago. The universe is vast beyond imagination, and thanks to advancements like the James Webb Space Telescope, we're only beginning to understand how small we truly are and how much there is still to explore. A light-year away, the Andromeda Galaxy is hurtling toward us at a tremendous speed. As it approaches, our night sky will undergo noticeable changes. Containing around 1 trillion stars, Andromeda is on collision course with our own galaxy, the Milky Way, which houses approximately 300 billion stars. Despite the immense number of stars involved, the likelihood of individual star collisions is extremely low. This highlights just how vast space truly is and how rare direct interactions between stars can be, even in the event of galactic collision. While star-on-star collisions are unlikely, such galaxy mergers can stir up environments that may foster the spread or even emergence of life. Galaxies themselves are far from static. They are dynamic, ever-evolving systems. Zooming out from our Milky Way, we enter the local group, a small collection of nearby galaxies. Beyond this lies the Virgo cluster, home to more than 1,500 galaxies. Virgo, in turn, is part of an even grander structure, the Lana-Chaos supercluster, which contains about 100,000 galaxies. Each of these galaxies has hundreds of billions of stars and planets. Yet even this enormous structure represents just a fragment of the observable universe, which contains around 10 million superclusters. As we map the cosmos, we uncover more and more galaxies, but the ones we've identified are only a tiny portion of what exists. Hundreds of billions of galaxies remain unmapped. Adding to this cosmic scale is the cosmic microwave background radiation, the oldest detectable light in the universe. This faint glow is a relic of the Big Bang, offering insight into the universe's infancy. Beyond galaxies lie immense regions called cosmic voids, vast expanses with far less matter than the surrounding universe. These voids can span hundreds of millions of light years and, while seemingly empty, they may one day give rise to new galaxies and structures. Farther out still, we find cosmic filaments, enormous threads of dust gas and dark matter that stretch across billions of light years. These filaments weave the universe into a colossal cosmic web, linking galaxies and clusters through gravity. Matter in the universe isn't evenly distributed. Instead, it forms this intricate network where galaxies gather and interact at nodes and junctions within the web. Within this vast cosmic architecture, incredible phenomena occur. Supernovae, the explosive deaths of massive stars, scatter heavy elements across space, enriching the interstellar medium and forming the building blocks for future stars and planets. Black holes, with their intense gravitational pull, shape galaxy evolution and can emit powerful energy jets that extend light years into space. Also among the universe's marvels are quasars, extremely luminous and energetic objects powered by supermassive black holes consuming matter. These can outshine entire galaxies and act as lighthouses from the early universe, offering clues to its ancient past. But what lies beyond the observable universe? Many galaxies exist so far away that their light hasn't had enough time to reach us since the beginning of time. Due to the universe's continuous expansion, some of this light may never reach Earth, rendering those regions forever hidden from us. Based on current physics, scientists estimate that the universe is at least 250 times larger than what we can observe, perhaps even vastly larger. The idea of something being potentially infinite invites a broader perspective, one that compels us to reflect on the very nature of the universe and our place within it. As human beings on a remote planet in the vast expanse of space, contemplating such possibilities naturally leads us to ponder our existence and our role in the cosmos. Have you ever wondered just how immense the universe truly is? If so, I hope this video helped you grasp, even just a little, the incredible scale of the cosmos. Feel free to share your questions in the comments, and if you enjoyed the video, please give a like, share it to help others discover it, and subscribe so you don't miss future explorations. Thank you for watching, and I'll see you in the next video as we continue our journey through the universe. Our understanding of the cosmos is always evolving. Powerful tools like the James Webb Space Telescope have opened new frontiers that were once the stuff of science fiction. These instruments allow us not only to look deep into the early universe, but also to study the atmospheres of distant exoplanets, bringing us closer to answering one of the greatest questions of all time. Are we alone? In recent years, astronomers have discovered thousands of exoplanets orbiting distant stars. Many of these lie in the habitable zone, the region where conditions might support liquid water and, potentially, life. Some of these worlds resemble Earth in size and composition, while others are massive gas giants or icy planets with possible subsurface oceans. The sheer number, estimated in the billions within our galaxy alone, suggests that life-friendly conditions might be far more common than once believed. Yet the mysteries of the universe go far beyond the search for life. Consider dark matter and dark energy, which together make up about 95% of the universe's total mass energy content. Dark matter, the though invisible, exerts gravitational effects that influence the movement of galaxies and the structure of the cosmic web. Dark energy, on the other hand, is believed to be driving the accelerated expansion of the universe. Despite their significant effects, both remain elusive and largely theoretical. Then there's a fascinating concept of the multiverse, the idea that our universe might be just one of countless others, each governed by its own physical laws and possibly hosting entirely different forms of life or dimensions. These parallel universes could be completely disconnected from ours, or they might exist in higher dimensional space, accessible only through quantum mechanics or mathematical theory. While still speculative, the multiverse offers a mind-expanding view of what might lie beyond our own cosmic horizon. Time itself is not as fixed as it may seem. According to Einstein's theory of relativity, time slows down in the presence of strong gravitational fields, a phenomenon known as gravitational time dilation. For example, time would pass more slowly on a space station orbiting near a black hole compared to Earth. This has been confirmed by experiments and has deep implications for our understanding of space, time, and even interstellar travel. Black holes, often thought of as cosmic vacuum cleaners, are much more than that. At the center of nearly every large galaxy lies a supermassive black hole, millions or even billions of times more massive than our Sun. These colossal entities influence galaxy formation, regulate star birth, and can emit jets of energy that span entire galaxies. Even more speculative are wormholes, hypothetical tunnels through space-time that could theoretically link distant regions of the universe or even different universes altogether. Although still unproven and riddled with theoretical challenges, wormholes continue to captivate both scientists and storytellers alike. And yet, amid all this vastness and wonder, here we are, an intelligent species on a small rocky planet, circling an ordinary star in a quiet region of a single galaxy among trillions. Despite our humble beginnings, we possess the ability to ask the big questions, build tools to explore the cosmos, and imagine realities far beyond our reach. Every image captured by a space telescope, every faint signal received from across the stars, every subatomic particle detected in underground labs, these are all steps in our pursuit of knowledge. Bit by bit, we chip away at the unknown, illuminating the cosmic darkness and expanding our understanding. So, the next time you look up at the night sky, remember, you're not just seeing stars. You're looking into the past, into the structure of space-time, into questions that remain unsolved. The universe is not only vast, it is a mirror reflecting our endless curiosity and our drive to understand.